Okay, welcome everybody. In today's lecture, we're going to talk about discontinuous forcing functions and using Laplace transforms to solve ODEs where we have discontinuous forcing functions. So in the last section, and way back in chapter 3, we studied equations, of which this is one particular example. On the right-hand side, we have a constant coefficient second order linear ODE. And it's inhomogeneous because we have some right-hand side. It's inhomogeneous as long as G is not equal to 0, and G is the forcing function. And this, as we saw earlier, models what we call a simple harmonic oscillator. And this G of t is our forcing function. Okay. And so you want to solve these kinds of ODEs and other higher order ones too with inhomogeneous terms because they serve as the forcing functions. And a lot of times your forcing functions are discontinuous. So let's, for right now, suppose that this forcing function for us, let's take the special case of, let me do it this way. Let's let G of t be U5 of t minus U20 of t. So that means it's a function, if you remember what happened before with a function like that, that would mean between 5 and 20, it takes on the value 1, and at 20, it goes back to 0 again, okay? So for this one, you have a harmonic oscillator, and as long as t is less than 5 or greater than 20, there's no force acting on it, but when t is between 5 and 20, there is a force, and now we're just setting the force equal to 1. We could have made it more complicated by multiplying by something, but we didn't, okay? All right, so, look, we need some initial conditions. So let's take y of 0 to be 0 and y prime of 0 to be 0, okay? Okay, so how do we solve this equation? So how do we solve this equation? So we're going to try to solve it using Laplace transforms. So I take the Laplace transform of the whole equation on both sides. So that will give me the Laplace transform of 2y double prime plus y prime plus 2y is going to be the Laplace transform of u5 of t minus u20 of t. Okay, so we know the Laplace transform is linear, and we know how this behaves and how the Laplace transform takes the second derivative and gives you back s squared times capital Y, where capital Y is the Laplace transform of little y. Okay. And then you will get minus sy of 0 minus y prime at 0. So that's the Laplace transform of the second derivative, but all that gets multiplied by 2. And then I have plus the Laplace transform of y prime, which will be s capital Y minus y of 0. And then here I'll have 2 times capital Y. And that's going to be equal to the Laplace transform of u5 of t. So if you look that up, that's u5 of t times 1. And so the Laplace transform theorem that we had before says that's going to be the Laplace transform of 1, which is 1 over s. But then you have to multiply because because of the u5 term times e to the minus 5s. And then with the 20, you'll have a 1 over s because it's multiplied times 1, and you have an e to the minus 20s. Okay. Hopefully you can read that. Okay, so, all right. So now let's see what we have left. Now y of 0 and y prime of 0 are both 0. So this goes, and this goes. And everything else on this right-hand side has a y in it. So let me factor out the capital Y. And then we have 2s squared plus s plus 2 is equal to e to the minus 5s over s minus e to the minus 20s over s. So y of s is equal to e to the minus 5s divided by s times 2s squared plus s plus 2 minus e to the minus 20s over s times 2s squared plus s plus 2. Okay. Okay. So now notice that basically this thing is e to the minus 5s times this, and it's e to the minus 20s times this, and those two pieces are the same. So you remember our theorem said if you have e to the minus cs times g of s, then the inverse Laplace transform of that, when you look up on the table, the inverse Laplace transform of that is going to be uc of t times g of t minus c, where g was the function you got as the inverse of the Laplace transform of capital G. So to do these two pieces here, basically, I'm pretty much done if I can figure out what the inverse Laplace transform is of 1 over s times 2s squared plus s plus 2. So that's what I got to work on first, and then I can put this back together. So for us, the g of s, the capital G of s, here that we'll think of is 1 over s times 2s squared plus s plus 2. Okay. All right, there's nothing even close to that in the tables. Okay. So, and 2s squared plus s plus 2 does not factor, right? Let's think about that. No, I believe that's true. That does not factor. Okay, so basically we're going to have to use a partial fraction decomposition. So that means we're going to want to do something like a over s plus bs plus c over 2s squared plus s plus 2. Okay, and we have to work that out. All right, so multiplying through by the denominator is going to say that 1 is a times 2s squared plus s plus 2 plus bs plus c times s. Okay, so let's see, on that gives me over here, that gives me a 2as squared plus as plus 2a plus bs squared plus cs. And now I equate coefficients from the s squared term, and skipping, from the s squared term on the right-hand side, my coefficient, on the left-hand side, the coefficient is 0. On the right-hand side, it is 2a plus b. From the s term, on the left-hand side, the coefficient is 0. On the right-hand side, the coefficient of the s terms is a plus c. And from the constant terms, on the left, it's 1. And on the right, it is on the right, it is 2a. Okay. So that says a is a half. This says a is equal to minus c. So c is minus a half. And 2a plus b equals 0. Well, 2a is 1, so this says b is equal to minus 1. Okay. All right, so this was pretty darn messy. So let's see, my g of s then can now be written as it's 1/2 times 1 over s. That one's easy to invert the Laplace transform of. That one we got. And then b is -1 and c is -1/2. So let me just write it as a minus sign out in front. And then we'll have an s plus 1. That's my bs plus c over 2s squared plus s plus 2. Okay. All right. So this one is easy to invert. This one we have to work on a little bit. So when we work, what am I going to have to do to this one? So this will be 1/2 times 1 over s, because the 1/2 is going to stay out when I go to invert that. And now for this one, what am I going to do? This looks really kind of hopeless. Well, let me factor out a 2 and then complete the square in s. Well, that's going to be 2 squeezed in down here. Let me go here. And you see, you have to do something, and there really is nothing else you could do other than to try to complete the square in s. But if you remember your high school algebra, and you have to, you can't complete the square, or the formula isn't very nice unless you factor out and make the coefficient of the square term 1. So this will be s over 2. And now we leave a blank space, and then we have a plus 2. Upstairs, it's s plus 1. Okay. So now I take half the coefficient of s. That'll be a 4th. I square it. I get a 16th. But I added 2 over 16, which is 1/8. So I better subtract an 8 here to compensate for that. Otherwise, I've added something other than 0. Okay. So let's see. Then that gives me g of s. We still have the 1 over half times 1 over s. And now what do we have here? So, excuse me, this is going to be s plus 1 over 2 times, this is s plus 1/4 quantity squared. And that's 16 over 8 minus 1 over 8 is minus 15 over 8. Okay. Okay. And so let's see. This is pretty darn yucky. Well, what's the best way to proceed with this? Why, I'm sorry I picked this one, but anyway, here we are. Okay, so this is 1 over 2 times 1. Yeah, I'm not going to do that there. 1 over 2 times 1 over s. I'm going to factor out a 2 here, so I'll have a 1/2. Now be very careful with your algebra. So you have s plus 1 in the top. You factored out a 2 from this term. That gives you an s plus 1/4 quantity squared. If you factor out a 2 from here, that gives you a minus 15 over 16. How do I know that's right? Because if I multiply that 15 over 16 by 2, I have to get back to 15 over 8. So that's correct. Okay. Now, the problem is, if you try to look this up in the chart, you can't even find this, because here, here you have an s plus 1/4. And so in the chart, you need an s plus 1/4. So we have to break this itself into 2 different pieces. So this will be S plus 1/4 over S plus 1/4 quantity squared minus 15 over 16. And let's see, was that a minus or I'm sorry, I had 16 over 18, 16 over 8 minus 15 over 8. Sorry, said it wrong. 16 over 8 minus 1 over 8 is a plus 15 over 8. So this is a plus, this is a plus, this is a plus. Okay. So I took 1/4 of this one and included it here. That means I'll have 3/4 over here. And I know a lot of you had trouble with your algebra on the first test. You have really got to get your algebra skills in tune here because this is not trivial algebra. Okay, now we're almost good because we can look up a lot of these things in the charts. Um, uh, okay, but you have to be a little bit careful. Now, when you look up on the chart, this one's easy. So if we want to get back little g of t, we start taking inverse Laplace transforms. So if you look up the inverse Laplace transform of 1 over s, let's see, um, I have it open to my chart over here. If you look up 1 over s, you get 1. So the inverse Laplace transform of 1 over s is 1, and then you had a half. Okay, so it's a half times 1. So now I'm going back to the chart, reading from right to left. And now when you look on the chart, you will see a line. And in fact, in the one in your book, it is the line 10. This one's line 10. You have s minus a over s minus a squared plus b squared. So line 10 looks like s minus a over s minus a squared plus b squared. And then when you invert that, you get e to the at e to the at, let me make sure I'm looking at the right one, times cosine bt. Okay. All right, and that was from line 10 on the chart. So now when I look at this one, that's exactly of that form with a equal to minus 1/4 and b equal to what? Well, this has to be b squared. So that's the square root of 15 over 4. Okay. So this becomes e to the minus t over 4 times the cosine of the square root of 15 over 4t. Okay. Now, when you try to look up this one in the chart, you have another line on your chart. In fact, it's line 9 that says if you have b over s minus a squared plus b squared, and you read to the other side, that gives you e to the at sine bt. Okay. So this one is almost in that form, except what do you need? You need the square root of 15 over 16 as the numerator. So what we need in this numerator, not 3/4, but we need square root of 15 over 4. So I will put a square root of 15 here and a 1 over square root of 15 out in front to compensate for that. And the 3 is going to come outside and hang out with the, let me get back to my Zoom window. Oh, Jesus. Okay, and the 3 is going to come out and hang with the constant because we don't need that in there. The formula just has b, and b squared has to be 15 over 16. So now when we take that into account, we have a plus Now I'm going to invert that Laplace transform using this formula from 9. So we had the 3 came out in front, the square root of 15 we had because we had to put that in there to compensate. Now we have the square root of 15 over 4 at the top, s plus 1/4 quantity squared plus square root of 15 over 4 quantity squared. So by number 9, with a equal to minus 1 over 4 and b equal to the square root of 15 over 4. For this one, we get an e to the minus t over 4 times the sine of the square root of 15 over 14. Okay? And that's the solution to the ODE. Okay. And yes, there's a lot of the basic idea is very easy, but the algebra itself is really kind of messy. Okay. You could do this basically by a different method if you wanted to. If we go back to this original problem. So you could look at this problem where the right-hand side is u5 of t minus u20 of t, but you would have to solve 3 different ordinary differential equations problems. One on the interval from 0 to 5, in which case you get just the forcing function of 0. Another on the interval from 5 to 20, where you get that the forcing function is 1, because this one's 1 and that one's 0 on the interval from between when t is between 5 and 20. And when t is bigger than 20, you have to solve again with the forcing function 0. And on the second 2 intervals, your initial conditions have to begin, like on that last interval, the initial condition has to be, y at 20, y prime at 20. So you have to check what's the solution from the previous interval so you can find that value there. Okay. So it's not easy to do it by the other method either. That's quite long if you try to calculate that. Okay. Okay. All right, let's do one more like that. I promise this one won't be quite as long. So let's do another example. Or at least I don't think this one will take us quite as long. Suppose we look at y double prime plus 3y prime plus 2y equals f of t. Y of 0 is 0, y prime at 0 is 0, and f of t is the function that's 1 if t is between 0 and 10, and it's 0 if t is greater than or equal to 10. Okay? Okay, so you have to find the solution to that problem. All right, you won't find anything like that in the Laplace transform charts. You have to write it in terms of that heavy side function. So now we want this function to be 1 all the way up to 10. And we saw in the beginning, the pictures, that means we're going to basically need 1 minus u something. And since the break or the jump is at 10, we're going to guess it's 1 minus u of 10, u sub 10 of t. And now let's check. If t is less than or equal to 10, that's 1 minus 0, so that's 1. And if t is greater than or equal to 10, then this thing is 1, so that's 1 minus 1, so that's 0. So that's correct. Okay. So now we take the Laplace transform of the equation, and you do that on both sides. Of course, you must do the same. So that means this equation right here, the one we started with. Okay. So when you take the Laplace transform of y double prime, you get s squared times capital Y minus s y of 0 minus y prime of 0. Then we have 3 times the Laplace transform of y prime. So that's going to be 3sy minus 3sy of 0. Okay, and then I get 2 times the Laplace transform of y. And that's got to be equal to the Laplace transform of f. But the Laplace transform of f is, okay, you take a Laplace transform of 1. So that'll be 1 over s. And then you have to subtract the Laplace transform of u10 of t. So that is e to the minus 10s over s. Okay. All right, and now we notice that the initial conditions say all these extra terms are 0. Okay, and now the only things that's left on the left-hand side involve capital Y. So I'll write that and factor out the capital Y. And so that's equal to 1 over s minus e to the minus 10s over s. Okay, so I said it wrong, but I wrote it correctly. So y is equal to, all right, now I'm going to write it as 2 separate pieces. It's 1 over s times s squared plus 3s plus 2 minus e to the minus 10s over s times s squared plus 3s plus 2. Okay, so again, like before, except for that exponential factor of e to the minus 10s, and we can compensate for that later. Oh, geez, I forgot. Okay. We have to go back to that problem we did before. We didn't quite finish all of that. Okay, so I'll go back to that in a minute. I found the inverse Laplace transform of g, but that didn't finish the problem. So we'll go back and fix that. But basically, this piece, and except for this exponential term, this piece, they're the same. So that's my capital G of S. I need to know what's the Laplace transform of this guy. For this piece, that'll do it. For this piece, I have an e to the minus cs times the Laplace transform of something I know. Okay, and then I'll have to work with that on the chart. Okay, so let's go on and try to find the inverse Laplace transform of G. Okay, now in this case, this guy factors this s squared plus 3s plus 2. That factors to s plus 2, s plus 1. So G of s is 1 over s times s plus 1 times s plus 2. Okay. All right. So if I want to write that out in a partial fraction decomposition, that's a little easier than before. Let's call it a over s plus b over s plus 1 plus c over s plus 2. Okay, and now we work out what that says, multiplying through by the denominator. On the left, I get 1. On the right, I'll get a times s plus 1 times s plus 2. So that is as squared plus 3s plus 2. Here I'll get b times s plus 2. So that's s squared plus 2s. And then I'll have c times s plus 1, which is s squared plus s. Okay, so that says 1 is as squared plus 3as plus 2a plus bs squared plus 2bs plus cs squared plus cs. So equating coefficients from the squared term, I have a plus b plus c. And on the left-hand side, the coefficient of the square term is 0. So a plus b plus c equals 0. From the s term, on the left, I get 0. On the right, I get 3a plus 2b plus c. And from the constant term, on the left, I get 1. On the right, I get 2a period, right? Okay, so that says a is a half. Okay, so now this equation, the s squared equation, says b plus c equals minus a half. And this equation with a equals a half says 2b plus c is equal to minus 3 halves. So now solve it by your favorite way for two equations and two unknowns. But what you'll get if you do that is that b is a half and c is minus 1. Solving two equations and two unknowns should be easy for you compared to everything we're doing. So that says that g of s then is written as 1/2 times 1 over s plus 1/2 times 1 over s plus 1 minus 1 over s plus 2. Okay. And so the inverse Laplace transform of that okay, so the inverse Laplace transform of this function is, let me get back to my chart. Okay, when you look up 1 over s on the left-hand side and you look back to the right, you'll see that's 1. So the inverse Laplace transform of 1 over s is 1. That's line 1. If you look up the inverse Laplace transform of 1 over s minus a, you will get e to the at. So here, s minus a means a is minus 1. So I get e to the minus t times a half. And here it's the same thing, but a is minus 2. So you get e to the minus 2t. Okay. That's not quite the end of things because if you remember, y was capital Y of s. Capital Y of s was g of s, that's this one, minus e to the minus 10s times g of s. Okay. And let me get back to where I'm looking at my screen that I'm showing you. Okay. All right. And so now I'm ready to invert this to get the solution y. So y of little t is you take the inverse Laplace transform of the g. We already found that. That's 1/2 plus e to the minus t over 2 minus e to the minus 2t. Plus, now if you look at your Laplace transform chart, you will see that if, I believe it is line 13. So for this one, use line 13. And you will see that the inverse Laplace transform of e to the minus cs times g of s is u sub c, and here c is 10, so this will be u10 of t times the original function, so the little g evaluated at t minus c, and c is 10. So g evaluated at t minus 10. So this will be 1/2 plus e to the minus t minus 10 over 2 plus e to the minus 2 t minus 10. Oh, I can't fit that in there. Plus e to the minus 2 t minus 10. Okay, and that's the solution. Okay, so yeah, we had one more step to go on the previous problem, and I just forgot to go back and finish that. So this is back to the previous example. We found that little g the inverse Laplace transform of capital G was this guy. But remember, our original function that we had to get the inverse Laplace transform for was capital Y. So capital Y was, in terms of G, so capital Y of S was e to the minus 5s times G of S minus e to the minus 20s times G of S. So again, using, I believe that was line 13, you will get that this is u sub 5 of t, inverting this Laplace transform to get little y back. It's u sub 5 of t times g, little g at t minus 5, minus, this one will be u20 of t times little g at t minus 20. And we found the little g before. It was all this mess. So now you get to write all that out. So y of t is u5 of t. And now we write g at t minus 5. So that's 1/2 minus 1/2 e to the minus t minus 5 over 4 times cosine square root of 15 over 4 t minus 5 plus 3 over the square root of 15 e to the minus t minus 5 over 4 times the sine of the square root of 15 over 4 times t minus 5. Plus, minus u20 of t. And now you play the same exact game, but instead of 5, it's 20. So this is 1/2 e to the minus t minus 20 over 4 cosine square root of 15 over 4 t minus 20. Okay, and this should be all of the same line. This is all inside the parentheses, plus 3 over square root of 15 e to the minus t minus 20 over 4 sine square root of 15 over 4 t minus 20. Make it a square bracket to emphasize that. Whew. Okay, and that finishes the previous example. All right, so that's the end of the lecture for sections 6.3 and 6.4. And we'll meet on Wednesday for a question session. Okay, bye.